This is a session in the series of bibliometric analysis. You might like to go back into the playlist to check on session number 1 to session number 5. In this session, we are going to particularly talk about citation analysis, which comprises of two major ways. One is co-citation analysis and the other is bibliographic coupling. We will be seeing how to do it in VOS Viewer, which is the software freely available and easily you can download on your system. I will show you how to download this system. VOS stands for Visualization of Scientific Landscapes. So that helps us to see the networks amongst the authors, institutions, journals, articles, and their nations. Now, let us go into the details and check out how it is actually done. Citation analysis helps to map the intellectual and social structure prevalent in research. It is of two types, co-citation and bibliographic coupling. What is the difference? The difference lies here is that when two documents, say document A and document B, here the document means an article. So when A and B both are cited by a third document, which is document C, then these A and B are said to be co-cited by the third document. This is co-citation. When A and B both have the same references quoted by them in their article, that means at least one similar reference is there. Maybe there are 2, 3, 4, 10. In that case, A and B are said to be coupled, or the analysis is known as bibliographic coupling. So when we do this analysis in VOS Viewer, we get a map in which we can see a node which has a particular color, which signifies the cluster which it belongs to. Nodes of the same color belong to a common research ideology or a theme. Thus, it infers a strong relationship within the members of those clusters. Node size tells us the significance or impact of the represented item. It may be an article which you have chosen for the analysis. It may be an author-wise analysis or a journal-based. Example, a larger node size often signifies a higher number of citations received, which indicates greater influence or prominence in the field. So larger the node size, larger is the number of citations received by the document. So this citation analysis basically works on the principle of citations, and it considers that higher the number of citations, greater is the influence or prominence in the field. Internodal distance. Now there will be some distance between two nodes, which signifies the relatedness or strength of connection. Shorter the distance, stronger the link, and higher is the thematic closeness. Right? So that means all those are working together on a particular theme. That is why they are belonging to a particular cluster and their distance is close to each other. This is what we have already discussed. Let us recap before we go into VOS Viewer. This technique involves analyzing the frequency with which two or more publications are cited together in other publications, which can assist in identifying seminal articles, foundational articles, and historical structure in the field of study. So seminal articles are the foundational, important landmark articles in that field. So it helps us to identify that. And it can be author-based, article-based, nation, or journal-based. You have to make a selection over there. I'll show you in VOS Viewer how you make a selection on these four. Out of these four, you have to select any one. It depends upon citations to measure articles' impact, and new articles need time to come at the level of older articles. So this is a drawback of co-citation analysis, that it depends upon the citations to measure the article's impact. Whereas we see that the new articles which have just now been published will need some time to come up to that level of older articles, but the co-citation analysis does not consider them because this is solely on the basis of citations. In bibliographic coupling, however, it can be used for new articles, but it does not help to identify the most significant articles, which is done through co-citation analysis. By most significant, we mean the articles which have received the maximum number of citations. This technique involves identifying the articles that have one or more common references, which can assist in identifying recently evolving fields in a selected research domain. So now I hope the difference between co-citation analysis and bibliographic coupling is quite clear to you. And now we are ready to go into WASP Viewer. First, I'll show you how to download it, install it, and then take a Web of Science file from Web of Science, how to perform the advanced search in Web of Science, download the data, upload it, import it in WASP Viewer, and then do the analysis. So let us start. Here you see I'm in my Google browser. In this, I just need to type in WASP Viewer. So the first site which I get was Viewer Visualizing Scientific Landscapes. So this is the website. So it clearly says that you can download the WASP Viewer from here. The current version is 1.6.20. So we download it. Then it asks us the configuration of our system. WASP Viewer for Microsoft Windows, for Mac operating systems and other systems. Since this is a Microsoft Windows system on which I am working, I'll select this one and it will be downloaded onto my system. So once it is downloaded, we have to open this thing and then use it. So now you see the WASP viewer has been downloaded. It's a 60.3 MB file. It's in zipped format, so I need to open this thing up. I just click on this and I go to the WASP viewer, and this is the application. So after opening the WASP viewer, you'll see an interface something like this. This is the WASP viewer interface where we need to import a file. So from creating a file, you choose a type of data. Now, where do we get the data from? I'll take you to Web of Science and see how to download the relevant data for the analysis. So here we are in our Web of Science advanced search. You see I have selected topic. What does it mean? Topic searches the title, abstract, keywords plus and author keywords. So whatever I'll be typing over here in the query, it will be searched in the title, abstract and the keywords and the keyword plus of that article to give me the relevant articles. Say for example, I want to perform a search on AI and academic writing. So I have to type it like this. I've shown it in my previous videos also, how to build a query. So AI is a single word and academic writing comprises of two different words. It's a bigram. So that's why I put in inverted commas and in between I put in and. So just click search. So when I click on search, you see this has given me 412 records. Now I can perform a filter search over here as per the years of application, or I can just search the review articles. Document types, I'll select article, and yes, so many things which you can filter out based on subject area, linguistics, computer science, language linguistics, educational research. You can filter out whatever is relevant to you. So I got 341 relevant articles. Now I need to export it. I go to export and I have to export it in plain text file because that is the format which is accepted by the WASP viewer. So I click on record one from 341, all the records I want. And here I have to select full record and cited references, export. So this file will be exported in a plain text format. It will be there in my downloads folder. So now I need to go back into WASP viewer And here I need to click on create a map based on bibliographic data. Why? Choose this option to create a co-authorship, keyword co-occurrence, citation, bibliographic coupling, or co-citation map based on bibliographic data. So all these network analysis you can perform in WASP-Viewer. So I want to create a map. I click next, and then it says download data through API like OpenAlex, Crossref, Europe PMC, Semantic Scholar, and all. Then read data from bibliographic data files, which you have already downloaded. Since we have already got the file from Web of Science, I'll click over here and then go to next. Here, I tick on Web of Science. It's a Web of Science file, and then I import that file. So that's in my downloads. So I go to downloads and import that file. This is the saved record txt file. So I imported it and then click next. Now it will ask me the type of analysis which I want to do. A co-authorship analysis, a co-occurrence analysis, co-occurrence of keywords, citation analysis, bibliographic coupling, or co-citation. So here let us see bibliographic coupling. Unit of analysis, as I told you, it can be performed on different variables like documents, sources, authors, organizations, or countries. Similarly, if I want to do co-citation analysis, it can be performed on cited references, cited sources, and cited authors. For now, let us see bibliographic coupling based upon the articles. So documents is there, articles and documents is the same thing. And this is counting method. What does it mean? One great feature of WASP Viewer is that when you go on this question mark, it will tell you what all it is. You see, it tells you what is co-authorship analysis, what is co-occurrence, citation analysis, bibliographic coupling, and co-citation. Everything is here. That's a great feature. You don't need to go into Google to find out or ask someone what does it mean. Counting method also, it says the full counting means that each co-authorship, co-occurrence, bibliographic coupling, or co-citation link has the same weight. Say for an instance, I'll explain you in a simple term. An article which was authored by three different authors. So if I do full counting, then in that case, each of the authors will get at least one citation for that document, right? If I click on fractional counting, which is a better way of assessment, a more logical assessment of the contribution of the authors, in that case, each author will be credited with 1 by 3 citation. So the calculation will be performed on that basis. We can go with full counting or we can go with fractional counting. It is advisable by recent research articles as well that we should go in for fractional counting to get a better assessment. So I click on fractional counting and then I go next. Now it shows minimum number of citations of a document. I need to do a selection over here. So if it's 0, then it selects all the documents, right? So if in the area of study, I'm familiar with the area of study which I'm performing, I know that at least each document should have 4 or 5 citations to be included in this analysis. That shows the significance or importance of that article. Otherwise, that article might not be meaningful or important to be included in this analysis. So I put this threshold of 4 over here. That means if each of the article has 4 citations at least, only those articles will be included in the analysis. So it says of the 341 documents, only 133 meet the threshold. So I'm okay with that. I'll be getting the analysis on 133 documents only. I click on next, and then for each of the 133 documents, the total strength of the bibliographic coupling links with the other documents will be calculated. The documents with the greatest total link strength will be selected, right? So then next, and you see here all the author names and year of publication, the citations they have received, and the total link strength. The higher the link strength, the better is their citations. The more citations they have got, and their research is more impactful. Then I click on finish. So it says some of the 133 items in your network are not connected to each other because it is filtered on the basis of citations, the threshold which we gave to it. That is, each document should must have at least 4 citations to be included, right? The largest set of connected items consists of 129 items. Do you want to show this set of items instead of all items? Yes. So I go with yes, and this is a beautiful map which is given to us by WASPviewer. Now, if I want to see the items, I go to items and it shows me the different clusters which are formed, right? So as I can see, red, purple, blue, green, and yellow. I can see 5 clusters over here in this image, out of which I feel red is the most dominant one. So let us see how many clusters are being shown. It shows 8 clusters, right? But I see that there are majorly 5 clusters: red, purple, blue, green, and yellow. So I'll take them at those 5 major clusters. So here you have, you see, cluster 5. So when I write 5, it will show me cluster 1, 2, 3, 4, 5. So it shows me the items in those clusters as well. Items means the documents. So these are the documents, 7 documents, 1, 2, 3, 4, 5, 6, 7. 7 in cluster 1, right? So then cluster 2 has 5 items, cluster 3 has 10, 4 has 11, and 5 has 3, 6 has 4. Now, now it depends on me as a researcher that if I feel that which clusters I should analyze. I need to conduct a systematic literature review. I need to do a literature review and find out what were the findings, what were the gaps, what are the future scope of study in that area. So in that case, I need to make a decision over here that which cluster should I include in my study. So I'll include those relevant clusters which have at least, I'll make up a threshold that they at least have 10 items in them. So if I consider that in that case, I have cluster number 4 having 11 items, cluster number 3 having 10 items. 2 clusters are there, right? If I make the threshold as 5, then I have 3. So that is how I decide, and then I go about discussing those papers in a bibliometric SLR paper, bibliometric systematic literature review. That is how I do it. And if I go to analysis, you see over analysis, the method is association. So there are other methods also, but it is advisable to go with association strength method. That is the most widely used, and it is set default by default in WASPviewer. So this is how you do it. You can export it. You go to file and you go to screenshot and copy to clipboard. If I click on copy to clipboard, this image is copied and I can put it in my Microsoft Word file easily, right? Here is the manual which you can see. When I go to open this manual, it will show me what and how to operate WASP viewer. So different things are there and how to read the results. Everything is mentioned in this manual. So you can go through this manual as well and learn it, right? So this can also be, there can also be cluster colors. I can edit the colors of the clusters. Say for an instance, instead of red, I want it to be green. So now you see, in place of green, I want it to be again red. So I can change the colors of the clusters like this. And then colored lines, if I untick the colored lines, the lines become grayish in color. And if I say curved lines, I don't want curved lines, then I get the straight lines. You get the straight lines. Okay, so this is how you do it. And then circles or frames, I want circles or frames like this. So if it's easily readable, it's quite legible to you in a frame form, then you study it through a frame form. Otherwise, you can go in for circle as well. So weights over here is based on citations. So or we can take total link strength. So if I go by total link strength, I'll get something like this. If I go by normalized citations, I get something like this. I'll show you something more. So if I go with this thing, overlay visualization, I ticked on overlay visualization. You see, Bolanos 2024 is closely linked to Fabiano 2024. That means they have more citations in common. They have more references in common. So Fabiano and Bolanos have more citations in common. Whatever they have referenced in their articles, they are mostly the same references in them. And then if I see Bolanos and this Salih, so if I say SALIH, so I'll see the distance is also larger, and then it means that there'll be lesser number of common references between Bolanos and Salih, right? Similarly, Bolanos and Tang, the distance is a little away, not as close as Bolanos and Fabiano. So that means there are lesser references in common. Whatever Bolanos has referenced, Guler has also referenced, but the distance is larger. That means if Bolanos had four common references with Fabiano, taking for an instance, then Bolanos would have only one common reference with Guler. That is how you interpret it. Okay, because closer the connection, higher is the commonality of references given by them, and bigger the size of the circle, bigger the size of the node means that document is having more common references. Then I go to density visualization. Here you see a heat map. Heat map visualization. Again, you see the areas marked in yellow. They are denser and they are at the middle. So that means the ones located at the core of the network has a solid central influence on AI and academic writing research area. So that is what we infer from this, right? So the ones at the center of each cluster, you see, they have a solid influence. They are quite impactful in that area, what we are searching, AI and academic research within that cluster, right? And what are the keywords they are working on? We can check through co-occurrence of keywords, right? Co-word analysis. We can do a co-word analysis to find out which clusters are working on majorly which keywords. So I end the session over here and see you in a next meaningful session on bibliometric analysis. Keep watching and do share the content with your friends and faculty colleagues. Thanks a lot.